Okay guys, this is the third problem for chapter 5.2. This is another in-class example. It's number 6 of the examples he gave us. We're going to prove the following using mathematical induction. 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus n cubed is equal to n squared times the quantity n plus 1 squared is all over 4. I'd like you to please pause the video now and try to work out the problem on your own. And when you're done, unpause the video. Okay, I'm going to get started. So, as always, aside, and I'm just going to change this written out summation or notation to summation notation. That's a sum from k equals 1 to n of k cubed is equal to n squared times n plus 1 squared all over 4. Now we're going to do a base case. We're setting n equal to 1. We're asking if 1 cubed is equal to 1 squared times 1 plus 1 squared all over 4. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. This is equal to 4 over 4. 1 cubed is 1, so we have 1 over here. I'm going to take up so much room. And we have 1 over here. So we have proven that the base case works. Now it's time for the induction hypothesis. And we are setting n equal to L. So that is the summation from k equals 1 to L of k cubed is equal to L squared plus L plus 1 squared all over 4. Now it's time for our induction step. I'm setting n equal to L plus 1. So I'll start with my summation here. The sum from k equals 1 to L of k cubed. Now I need to add one more iteration, so it's L plus 1 cubed. Is equal to, again, I will replace every instance of L with L plus 1. So this is L plus 1 squared. So the second thing would be L plus 1, which is L plus 2. Quantity squared all over 4. This right-hand side of the equation is as simplified as I'm going to get it, so I'm going to leave it alone. Oops. We have our summation notation. It's the same as when it's n equals L, so I'm just going to replace it with the right-hand side of the equation. That's L squared, L plus 1 squared all over 4 plus L plus 1 cubed is equal to dot dot dot. I now have a fraction and a whole number. I'll find a common denominator, which is 4, so I will multiply 4 and then divide by 4. That leaves me with L squared times L plus 1 squared plus 4 times L plus 1 cubed all over 4 equals dot dot dot. I notice that I have L plus 1 squared and L plus 1 cubed, so I can pull out an L plus 1 squared out of both sides of this, and that's what I'll do. That leaves me with L plus 1 squared. On this side, I'm just left with L squared. And on this side, I'm left with 4 times L plus 1, which is 4L plus 4. All over 4. Now I'm going to factor the second parentheses. And just looking at that, again, how I normally do this, I'll show you guys. So I put my B term here, and my C term here. I'll put a little multiplication symbol there, and an addition symbol there. What numbers multiply to 4 and also add to 4? Well, how about 2 and 2? 2 times 2 is 4, and 2 plus 2 is 4. So whenever I see L plus 2 and L plus 2, that's the same thing as L plus 2 squared, of course. So this is equal to L plus 1 squared, L plus 2 squared, all over 4, which happens to be the right-hand side of my equation. So I'll write that one last time. L plus 1 squared, L plus 2 squared, all over 4, QED. We're done.